Hello everyone, and welcome to video 5 of this Introduction to ROS2 tutorial series. In this video, we're going to be covering the end of chapter 2. We're going to be covering custom ROS2 messages on your ROS2 network, and we're going to be closing off this topic about publisher subscribers, client servers, and action packages. So we're essentially finishing talking about nodes. And we're going to conclude that just by doing a review of what we've covered, just running through some of the commands, refreshing your memory. And with that, we'll kind of cover some of the strengths of DDS and why it's used as the communication model for ROS2. So you'll get to see that live. And in this particular video, this one will be shorter than the others. I don't necessarily recommend that you follow along in the same way that you have with the others. You're more than welcome to if you want to play around with the environments. But for this one, it's more of just like a review and kind of like a showcase of the strength of DDS for ROS. If you don't know what we're talking about, once again, go back to video 1 where we talk about what is ROS2 and what it's used for. What can you do with it? So in this video, we'll be reviewing DDS. We'll create a message that has multiple variables of data. So we'll have a more abstract data structure to send over our ROS2 network. And then we'll write a simple publisher for our message. And we'll just read the values from that publisher in the way that we have in the past to demo how some more complex data is shared across the ROS2 network. And throughout this process, we'll fill in some of the gaps in the command line versus the book, because once again, at this point, if you're going through the book side by side with these video series, you'll notice that in the book, they're kind of just assuming that, we've shown it once, you know how to run this stuff, you've seen it before, and if you get lost, if you're stuck on a part, you could just follow along here, because we're going to be doing everything. So just as a quick review, ROS uses data distribution service. And the real big thing I want you to take away in this video is the power of DDS being that we can exchange objects of data and, some more complex data messages than just raw data. And you'll see that in our message in this particular tutorial. And that is why ROS uses DDS as opposed to different communication models like UDP, TCP, where ROS1 very early in its development used those systems and then moved to DDS to really take advantage of, this more, we need more complex data streamed over robots. We don't want to be doing as much processing and having to deal with streaming raw data and then converting it into something that's useful for our particular action at a node. So that's why we're really um, fans of DDS and why there's so many options for different DDS models within ROS2. We're using fast DDS. Right now, I wouldn't worry too much, especially considering this is a beginner series. I wouldn't worry too much about messing around with the others, but just consider this one of the strengths of using this communication model, among other things that we've mentioned from video 1. Once again, this video series is meant as a companion to this reference book, where if you purchase the book, it's only $20 and you'll get a PDF copy, which is what I'm using on my computer. You'll get access to reference code from that book and also to the GitHub repo with a lot of the code that we're using. So, as usual, we're working in our virtual environment. And first thing we're going to do, I'm just going to move through this a little bit more quickly than usual because this is, again, just a review. So we're going to go into our source folder. Let's go ahead and grab the package that we're going to create. We're going to create a messages package. So just like we have in the previous 3 videos, we're going to store uh, our messages file inside of a messages package. And this messages file, we're going to go into that package and create it so that it stores multiple variables that we're going to stream over ROS2. So we're going to have a package that contains that message file, which we can then add as a dependency to other nodes in our ROS2 network. And when we create those nodes, we can basically create a node that either streams or takes in those different variable data types that we set up in this package. So we're going to create, we're going to create that package. We're going to go into that package, and then we're going to create a directory. And this is a pretty neat command in Unix systems where just directly in the command line, you can run two different lines. Like normally we'd run make directory messages, and then in the next line we would run CD to go into that messages directory. But just something to know, you can always write ampersand ampersand, just and, and that functions as like Boolean and you can run both of these lines together all at once. So we're making the directory and we're going into it. And then we're creating our messages file. So it's going to be called sine wave. Let's go to the GitHub, go to chapter 2. There's quite a bit of chapters, but towards the end, it gets a little more quick with the pace and more advanced. So we're going to go to the messages directory. And as you can see, this is a pretty simple file. So, um, whoops, we're in messages, message, sinewave.message, and we're just declaring three variables, frequency, amplitude, and signal. We're going to stream another sine wave, but this time rather than just streaming the value of the sine wave across time, we're going to stream the frequency and the amplitude of our sine wave. And you're going to see how, if you go back to the previous videos, we were just streaming data and the raw data. We're going to actually see in our message public, like under topics within the ROS network, we're going to see that that message actually contains this context where the particular value associated with the data that it's sharing is a frequency or an amplitude or a signal. And that'll help us when we're creating other scripts within ROS2, where now we can create a subscriber that reads that message and we'll actually have context as to what data is being shared. So you could think of this as like almost like an array of float values, a little bit more of a complex data structure. Maybe not necessarily what's going on in the back end, but uh, you know, now we can have multiple values that we're streaming over. It's almost, I would say more like a hash map where you have a key and then the float value that's associated with that. Now we'll see uh, the CMake lists file because we need to make sure that this messages file has the correct dependency that it needs. So we're going to go to CMake lists, grab this over so we can declare that we're using the standard messages dependency, which is right here. Here. And then we're going to go to packages XML, and then we're just going to grab, just like before with this previous publisher, just going to grab these dependencies, put them right in, and we're done. I'm just going to go around and save these files. And in this video, we're not going to run the build like Hulk and build and just verify this and all. I know that this works and you'll see that. So we're just going to, like we've done that enough times in previous videos, we're just going to move into our pub/sub file, our folder. We're going to create a new Python node where it's a publisher. We're going to call it SineWave Custom. I'm just going to quickly grab that. So that's going to be right here. And then before we fill in the information on this, we need to reference in our packages.xml file for the pub/sub package. We're going to reference that new messages file that we just created. So we can actually create a node that uses those three data types and those three variables. So we're just going to go and grab this dependency. You can write this yourself as well. You can kind of see like the trends here. Oh, wait. Oops, I left this in from earlier, but it's just right here. Messages underscore package when I was testing this. And then we'll go to our setup. We're going to just, I'll copy and paste one of these so we can edit it directly. We'll just add in an executable and give that a name. So we can call and run this new file. Subinplot, it's custom. So we've edited setup, we've edited packages.xml, and now we just need to include the contents of that new file. So we're going to go into SineWave Custom, and copy that, and then we'll talk about it a bit. But the only differences from the previous sinusoidal wave publisher that we created over here, SineWave Pub, if you look through them both, you'll see a lot of shared code. What's new is we're importing in that message that contains those three data types, those three variables, frequency, like a message with three variables, frequency, amplitude, and the value of the current sinusoidal wave. And by importing this in, we can use it in our new class of sinusoidal publisher, another node, where now our message will contain those three values over here, message sine wave, with variables stored within our objects that we can call using the names of the variables that we created in that message file. So frequency, amplitude, and then there's the data inside of that. And we're calculating signal here with that same formula that we used before. So now the message isn't just raw data about the signal wave. Now it's actually a three-part message that contains these keys, frequency, amplitude, and signal. And then well, as we'll see when we actually run this, we can see the name associated with the data next to it. So nothing too different from the past. So now we can just go here. We can to our terminal. We can go back to our ROS2 workspace directory so that we can run build, build our packages, build a new package that we just created, and rebuild the pub/sub package so that it actually contains this new content. And then we will run source install setup.bash. So we can set up the new environmental variables, set up our executable that we created. And finally, we're just going to actually run this node as usual. Just gonna grab that line. And now it's running in the background. So this node is successfully publishing information. And we can see that because if we go to another terminal, we can just run our topic list, which this was when we've created our first node, this was one of the things that we ran. So really going back to the beginning of chapter 2 as a review. And you can see here it is, our custom sinusoidal signal that we're streaming over the ROS2 network. And then if we run echo, we'll actually see the values being streamed over. And I'm just going to press Control C to stop this so we can talk about it. But in the past, we just saw this one line data. There's not even the name associated with it. And it was streaming just the value, the raw value of the data. And as opposed to other communication systems, imagine if we had these three values and we want to stream them, but they're all next to each other and we're just seeing 0.1 followed by 2 followed by negative 1.54. These three different flow values just in succession coming in as just data. You can imagine that when you're streaming that over the ROS network or streaming that over any network and you're trying to use that in another node, it's going to be difficult to differentiate. Okay, like you might have to time it, you might have to understand, what am I actually, um, from a developer perspective, what am I actually working with here? You have to do some post-processing on that data to actually like extract what you're trying to use in your new node. But in ROS, you can just reference it as hey, it's the frequency in my message, or hey, it's the amplitude in my message. That's what I'm interested in. Going back to our new file that we created, we're writing to that message object, and we're storing frequency, amplitude, um, and that's this is something that we can reference at any point. We can say, I'm just going to grab from the topic, I'm just going to grab the amplitude and I'm going to use that somewhere. So it's really the power of DDS because this is you know, a layer of abstraction that makes our lives easier when we can just say, rather than processing a raw signal and saying, hey, after a few post-processing steps, okay, I think this is the frequency. Hopefully I didn't get that wrong. Um, Especially with the code running, we're not going to be seeing that. The robot's just going to be doing its thing. No, we can say specifically, no, I'm interested in the frequency value and grab that data. So that concludes chapter 2. Congratulations on finishing the entire module on communication and ROS2. In the next few videos, we're going to be going into chapter 3 and making it slightly a little bit more advanced. We're going to be covering something really interesting in the next video that I'm excited about, the turtle bot simulator. Just very common starting point in ROS for actually like controlling a little robot. We're going to use a little 2D simulator. And within that, we'll talk about how to control your robot using a keyboard, which will be pretty cool. And as part of that chapter, we'll also talk about launch files. So we're starting to get into some more interesting subjects. And congratulations on really finishing a lot of the fundamentals here. So I hope to see you there. And thank you for watching as usual.